Hello, welcome to Picture Me Coding. My name is Erik Aker. Today, my co-host Mike Mole is with me. Hi, Mike.
Hey there.
Mike, you always tell me about interesting music you're listening to. That's one of the features of our show. I expect you have some this week. What do you got?
So I'm still combing through end of year lists for 2023. I don't follow jazz too closely, but always at the end of the year, I kind of look through the list and see what people were interested in during the course of the year. And came across a few things that I really liked. One of them in particular is this album called Melusine by the singer Cecile Mclorin Salvant. She's apparently American, even though the name sounds French. And most of this album is in either French or Haitian Creole. It's very interesting. Some of it sounds like very typical jazz, vocal jazz. Some of it sounds almost like pop music. Some of the tracks are just really, really beautiful. She has an amazing voice. So definitely recommend that one. There's another one that's mostly vocal. It's called "Where Are We" by Joshua Redman, who's a pretty well-known saxophonist.
Mostly vocal? There's no music?
No, it's vocal jazz, I guess is what I'm
okay.
saying. Most of the tracks have a vocal on them, but they're jazz tracks. The vocalist is named Gabrielle Cavassa, I believe. Anyway, it's called "Where Are We," and it's got this theme where all the songs are sort of place songs, like "I Left My Heart in San Francisco" and things like that. But there's one track in particular that I immediately loved, which is the track is called "Chicago Blues," but it's basically a jazz rendition of Sufjan Stevens' "Chicago" from
Oh,
the Illinois
wow.
album.
That sounds cool.
Yeah, I really enjoyed that. For that track alone, I would recommend this album. And then the third one is, you remember a few years ago when VJ Iyer put out this album called Uneasy?
I do remember that. Yeah, I liked that one.
Yeah, one of my favorite jazz albums of all time, I think. Anyway, the drummer on that was a guy named Tyshawn Sorey. And he put out an album this year called Continuing, which I've been listening to quite a bit too. Very interesting. It's only 4 long tracks. You can only get it on Bandcamp, but definitely worth it, I would say.
I'll give it a try. I've been stuck on more what I call peaceful feelings music. Innocuous music. I've been listening to Alberta Cross. Their album Sinking Ships came out last year. There's a song on there called Glow in the Dark, and it just gets stuck in my head. And the one they end with is called Every Time the Sun Comes Up. It's a nice song. And he sings, Every time the sun comes up, I'm in trouble. What does that mean?
It's a great line.
Calm, peaceful feelings music. Part of my mellow December, January. Let's just get through this time of year and wait until we wake up a little more in the spring.
I have a feeling we're going to need a lot of that in 2024.
Peaceful feelings music. Today we have a topic that brings a lot of animus up in me, I think. And that is, how do we deploy our stuff? We write software. It's not enough to just write it. It would be cool if we could just write it. Maybe like academics, we just write the stuff. No, we have to deploy it. We have to send it out into the world and have people interact with it. I have a lot of energy every time this topic comes up. It's sort of passion, I guess, is the word, because I've seen terrible deployments over the years, and it always takes a lot more effort and knowledge than I wish that it would. But that's probably the typical software developer's attitude. Mike, I want you to help me to start this conversation by telling me about your career in relation to deploying software. What have you seen? And ultimately, I'd like to know what are the features of when it has been good, when it has felt good to deploy software, and what are the potholes to avoid when it has felt bad. So let's start with what you've seen.
Well, reminding everyone again that I am very, very old, especially in software terms. So there's sort of like 2 large epics in my career with respect to deploying things. So up until roughly the turn of the century, let's say, it was basically you'd write software, you'd test it, you'd put it on some sort of physical media, and then you'd send it to your customers. So the deployment was largely the responsibility of the customer.
So you have a physical thing, like a CD.
Yeah, in the very early days, it was probably a floppy disk or a set of floppy disks.
Oh, wow.
Um,
Like a whole book of them. Epoch
yeah,
1, physical media.
right. Then we went through CD-ROMs and then DVDs, and I guess there was also a brief phase where people were downloading stuff from the internet, which is still largely the case.
Mm.
Um,
So a rollback in that scenario is, yeah, just put in the other disk that you had before we sent you the new one.
right. If you want to go from V1 point back to 1.6 from 1.7, you delete 1.7 and reinstall 1.6. So
Mm,
obviously were some cases where that wasn't the only thing you had to do. You know, there were enterprise developments where you might have to go on site and help people set up a database and things like that. I remember
hmm
I remember meeting people doing SAP deployments in like the late 90s, early 2000s, and this was almost kind of like a career unto itself. So these people would be on site for 6 months at a time, helping people do SAP deployments, and then they would get several months off before doing it
Wow.
again. So it was so you know there were variations there, but then around the turn of the century, early 2000s, stuff started to move to the web, and that's kind of the second epoch, which is largely, I think, what we're talking about today. You write the software, and then you have to get it onto some machine for the users to have access to it.
Hmm.
Um, in the very early days, you know, that was probably literally copying code to servers.
Right.
You mentioned the worst experience I've had. That was probably at the point I was working for a large internet company and had a service where I literally had to copy code onto 30 servers to do a full deployment. Um,
Manually, like you had to go to
yeah,
each of 30 servers.
each one at a time.
What was that thing you were deploying? What is the artifact?
So this is a Java application. So we were probably, in most cases, just putting a new jar file onto the servers and restarting Java. There may have been cases where we had to upgrade Java or change some configuration, garbage collection parameters, or something like that.
This is
Um,
making me a little nervous because those 30 servers probably live a long time and they probably have varying libraries and stuff installed on them.
yeah, and
They could be all over the place.
you end up with this situation where half your servers are running one thing before the other half have been patched. So yeah, anyway, that didn't last too long because obviously that was terrible.
It sucks.
And so you inevitably start making tools to automate that.
I want to
Um,
go back to the physical media because I have no experience with this aside from back in the day where I would download software from the internet and click the installer. And I mean, I guess I still do that, but
yeah,
paid software. What was a relationship with a customer like? What happens when that install fails? What's the actual thing you put on the CD? You build like a binary and it goes on the CD. I mean, what can you walk us through that a little bit and tell us also, were there good features of this method of deploying software?
usually this was code that was in written originally in C or C++ or something like that, and so the artifacts would be binary libraries and executables. In the case of Windows, which it mostly was at that point in time, you know, there would be DLLs, dynamic link libraries.
You didn't have to worry about compiling for different architectures.
To some extent, you did, and very often our QA teams would have vast numbers of machines with different Windows installations and in rare cases, different hardware.
Hmm.
The Intel line was pretty good about being compatible from era to era, but there was that there were those switches from 16 to 32 and then 32 to 64 and so forth. But yeah, so you know that at the time there was a piece of software that there was a type of software called an installer, and you know that would essentially allow you to run your users through a series of steps, you know, like a wizard type thing that would ask them for configuration stuff, and then that software would copy the the executables or the DLLs to the appropriate places. You hope.
And the folders and the files would have wings and they would fly across the widget.
in the good ones, yeah, yeah. And with Windows, there were registry things you might have to set and that kind of thing. Um,
Mhm.
a lot of times, you'd spend a lot of time actually QAing the installers, but the customers would inevitably get stuck on things or things wouldn't work, and that would probably facilitate or require a customer support call.
When you produced your binary and it's gonna go off and be made into like, you're gonna mint the thing, I guess. Does it go to a factory and a factory produces CDs for you, or you just is that part of the in-house process? Like, your company does that depending on how big it is?
Yeah, it depends on how big the company is. We had a team that actually produced the artifacts. So if it was a CD-ROM, let's say, we had a team that would burn them, and we did have a company that would produce the blank CDs with us, such that they were branded, so that when we sent them out to customers,
Mm.
they would have information about the company and the version of software and all that kind of stuff. The good old days.
I keep interrupting, but I still were there good aspects of this method of deploying software? What was good about it, if anything?
Well, I think the good thing from the standpoint of a developer is that most of the deployment falls on the customer. So if you,
Kick it over the real kick it over the wall. Kick
yeah,
that over the wall to the person who paid me for it.
yeah, and also, you could. It was pretty easy to duplicate what your customer was saying. So you could take a clean machine and install it on your clean machine, and see what your customer was saying. So it wasn't, not as it wasn't like having a web app where you're running literally the same software, but you could get pretty close to the identical setup. Um, there were a lot of companies back then, like big companies. If you were deploying your software into a big company, they might take your installer and just sort of rip the stuff out of it and add it to some asset manager thing that was pushing it out to all the employee machines, because very often the employees would not have the permissions on their own machines to install the media. So, and there
That
was
makes
the
sense.
strict control over versions and things like that. So,
Hmm. Hmm. Makes sense. I guess it's easier for me to imagine paying for this stuff if I get a physical thing out of it. Whereas if I'm just gonna like give you money and then download a thing that I can endlessly reproduce source code wise, it's harder for me to imagine paying for. That's a cultural brain problem.
yeah, I think that's probably why a lot of companies switch to sort of subscription like uh, price models, so that
Hmm.
you feel like you're paying for a service instead of a physical thing.
Hmm. Well, I think your experience definitely encompasses mine, so nothing that I've seen is going to be surprising to you. I first started working on websites and it was all static files, HTML, pretty much. And then, maybe HTML, CSS, JavaScript, and it was all just FTP static files over. And then when I started building more applications, it was around the same time I started using maybe Git. And so I would do a Git pull and probably using Apache. Maybe these are Python apps. So Apache has a module called ModWhiskey for Python at the time. And so I would SSH to a machine, I would do my Git pull, I would restart my app. If I had multiple virtual machines running the app, then they're in a pool, and Apache can load balance between them, so there's no downtime. And then that becomes a scripted thing. It's like, well, this is annoying to have to do. Do I want to do this once or do I want to repeat it? So you script the SSH get pull restart blah blah blah, that kind of junk.
Right.
Somewhere around 2000, maybe 11, 2012, I encountered Heroku for the first time, and I was pretty shocked. I encountered Heroku around the same time I encountered AWS. And Heroku, to me, deserves a special call out when you talk about deploying software, because there are aspects of Heroku that I think have really not been achieved by people who have made companies around deploying software or people who have made open source processes around deploying software. Heroku was phenomenal. You would do git push Heroku main and or git push Heroku whatever. You push your code up, and it would just they would deploy it, and you didn't have to do anything. You didn't have to manage virtual machines. You didn't have to make sure Linux is up to date. You didn't have to make sure that the libraries on your Linux virtual machine are up to date. It was phenomenal. If you wanted a rollback, you run get Heroku rollback. Heroku was started by these developers who were Ruby on Rails developers, and they wanted to make it easy for people to build Rails applications. And they ended up making this company that made it really easy to deploy Rails applications. And around the time they started the company, Ruby on Rails was hugely popular. GitHub was built on Rails. Twitter was built on Rails. A number of huge services were built using this. And it seemed like, wow, this is the way to go. This is how we're going to be building apps in the future. There's a popular term nowadays where we talk about how to make apps completely configurable. So they don't know what environment they're in. You can deploy them wherever. And that term is a 12-factor app. And a really common feature of 12-factor apps is that you inject configurations in. You don't have the app have some code that says, am I in dev? Then I will do something different. You inject configurations. And actually, the co-founder and CTO of Heroku coined the term 12-factor app. Heroku is this place that was innovative around deployment. Did you ever deploy anything to Heroku or use its services at all?
I don't think I ever did.
They had this super easy scaling. By default, you could have it scale to 0. And you could just say Heroku scale, whatever. They had this concept of these dynos. Dynos were kind of like how much compute you want to dedicate to your deployment. You could do like one click and you could spawn a PostgreSQL server and have your app connect to it. It was so magical. There are platforms today like Fly.io and Vercel that remind me a lot of Heroku. The drawback, and when I use Heroku, I use it to deploy Django apps. So they started with just Rails, and then they started to support Django, and they started to support some other ecosystems as well. The drawback that I saw in Heroku was you could deploy what they had configured, what they would provide, really. You could deploy Rails.
Right.
You could deploy Django. And that just is not going to work in the long run, I don't think.
Yeah, I feel like that's probably like an 80-20 solution. It works except when it doesn't. But there's so many cases where it works that it's probably still a worthwhile thing.
If people were still building primarily Rails apps, it's declined in popularity in the last 10 years. We could see this in trends, people looking for jobs and job listings. Rails is still, a great tool to use, but it has declined in popularity. And there's been this explosion of other web frameworks, and there's been the emergence of microservices, which is sometimes contrasted against the Djangos and the Rails, which are called monolithic applications. We probably could sidebar on microservices here, but I think we should save that conversation for later.
I think the problem that I would have run into with Heroku, and I don't know this for sure, but this seemed to be the case when I was working with stuff like Puppet in the 2010 era, maybe, where if you're doing plain vanilla Python and you're doing Postgres or MySQL, everything is great. But when you start throwing stuff like SciPy and NumPy into the mix, all bets are off because, it's gotten better and there have been attempts to solve that problem with things like Conda. But at the time, it was just, you ended up having to basically build those things on the platform that you were deploying to, and it was just a nightmare.
Yeah, I want to go back to that because that was my complaint with AWS Lambda when I first tried to use it. There are these axes that emerge in this conversation, I think. One is there's a series of concentric circles of how much do I want to manage and how much knowledge do I want to have. So, for example, I have a Python app. It's a web app. I want to run it. Okay, maybe I could there's some generic platform that can run a Python app. Okay, great. Maybe my app needs to talk to PostgreSQL and Redis. Okay, does the platform support those specifically? Okay, maybe I need load balancing. Maybe I need certificate management, certificate rotation. Maybe I need geographic load balancing. I need a load balancer to send traffic to my app in Florida and traffic to my app in Oregon. And things get complicated. Maybe I need DNS management. Maybe I need complicated networking setups. And the amount of knowledge it takes to correctly assemble in a secure way all of these layers of the onion is vast. And as a software developer, my ideal scenario is I don't want to know that. Yeah, okay, it's great. I know some of that stuff. I don't want to. I just want to write some cool code and ship it out to the world. And I want to have it work magically. And for my money, Heroku was the closest to that, but there's a fatal flaw there. I currently don't want to write Django apps. I want to write Rust apps. If I'm Heroku, I have to always be behind the eight ball supporting these various frameworks that people are going to want to use in the future. It's like we have to build a provider for that. It's just never going to work. When you go to the cloud, you now have the option to deploy whatever you want to virtual machines, but you're going to take a lot more ownership over those things. I mean, you mentioned Puppet, right? That's another. So in my experience with deployments, I'll just run through it real quick. Go from a brief experience deploying to Heroku straight to AWS, at a particular job. In AWS, we're configuring virtual machines and object storage and databases, and we're using CloudFormation for AWS or Ansible, and then later Terraform. And in Azure, they have this Azure Resource Manager stuff. Also, we use SaltStack and Puppet. And I saw people build similar to your artifact, your binaries. I saw people build RPMs or deb packages out of all kinds of stuff and try to ship it to a VM as a convenient way to do it. And then there's a huge thing that happens between maybe 2012, 2016 for a lot of people in our industry, and that's Docker. Docker can drastically reduce the variations in what I'm building and deploying because now I have kind of a universal binary, right? It's kind of the promise of the JVM realized. I can build whatever I want as long as I can get it into a Docker image. What about Docker? What do you think in terms of what you've seen in terms of deployments? Where would you put, well, maybe we could kind of rate these things. Heroku I put on its own little pedestal, but you've got physical media, you've got the equivalent of like Puppet, Ansible, or shell scripted junk where you're, maybe doing a git pull. Maybe you've got Docker. Well, what do you think? Where would you kind of rate these things in terms of how they changed deployments and made it better or worse?
Well, Docker was obviously a big step. I guess VMs to some extent too. And as we've talked about this in the past, I had a little bit of trouble accepting Docker. Obviously, I do now, and it's so pervasive that it's hard to imagine life without it. That said, every time I have to tweak a Docker file, I contemplate becoming a shepherd. I just really, really hate doing it. I guess we've got this embarrassment of riches, and I'm still complaining about it, but I quickly recognize and acknowledge the importance of Docker and the history of making deployments much easier, but I also still am very not in love with it.
I want to state some goals at this point before moving on. I still have some things that I used after Docker. Once I discovered Docker, it was like, okay, I need to automate pulling the latest image on my virtual machines and run, turning off the existing container and starting a new container. And that was pretty cool because if I can build an image, I have all the things I need in that artifact to run my application. And it doesn't matter what's in there. That was what I thought was cool about Docker. I could run a Haskell app, and I did in the past, build Haskell Docker images. I can run Rust, I can run Python, I can run whatever, as long as I can package it into that container. I think you're talking about frustration with having to deal with debugging a Docker file. There's a surprising amount of knowledge that sometimes goes into those sometimes because you'll have this Linux background you have to call on. Oh, I've got something I'm trying to compile and it fails and it needs OpenSSL and I have to update OpenSSL. Where is OpenSSL? This type of stuff that would be nice to shed, I don't necessarily care to know these things. It doesn't seem like valuable knowledge, but I have to successfully get builds sometimes. But I said I wanted to get you some goals. Here are the goals I have for deployment. I want it to be easy. And I associate that with I want it to be brainless. I want to not have to think about it. maybe that's my prejudice as someone who likes writing software. I don't want to deploy. I just want it to be magic and easy and brainless.
Agreed. We've talked about this a lot, and I think I'm never quite sure how much of this is a legitimate concern and how much of it is just that I am a curmudgeon. But, I kind of want it to be like the good old days when you'd write code and compile it, and then you had a program, and if you wanted somebody else to run that program, you just gave them that program. And every time I, find myself tweaking Docker files or changing pipeline files or making new Helm charts or whatever, I just kind of want to smack my head against the wall.
Okay, so my goals are easy, brainless. I want it to be repeatable, which I hope is self-evident, but means I can run it at 10 a.m. and noon and 1 p.m. and 4 in the morning, and it does the same thing. And surprisingly, there's some nuance to that. Does repeatable mean deterministic?
Yeah, I think also you want it to be repeatable, and ideally you want it to be fast. I guess that's another issue I have, is that it's nice having a repeatable process that doesn't involve any manual interventions, but if it takes a half an hour to finish, then it really loses a lot of its benefit to me.
That sucks, yeah. My goal, I have 4 goals I wrote down. I put easy, brainless together. I put repeatable. I put reliable. I think that's probably obvious.
Yeah.
You don't want it to break ever. And I put quick enough. I think there's maybe some subjectivity there, but for me, quick enough would be 5 minutes or less. Maybe there are people out there who are saying, oh, it takes me 30 minutes, and if I get it under 20, I'm happy. Maybe people out there saying it should be under 60 seconds. But generally, 5 minutes or less has been fine for me.
Yeah, I think that's acceptable. I admit occasions where I find a bug which is like literally a 2-character change, and it makes me really irritated that I have to go through the whole pipeline again to deploy that. But
open a pull request, get it approved, get it merged. So you've hinted a few times about pipelines. My experience post Docker, once I discovered Docker, I'm pretty sure I've probably said this before on the show, but I had this response, which was, wow, I can build and deploy whatever I want with this thing. Can somebody just start a company which will run my containers? I will give you money. Here's my container, run it, please. Run 20 of them, And that never quite materialized. I think there are some considerations in there that are pretty hard. I also saw over the years trends. For a while, people talked a lot about chat ops. That was where you would issue commands into Slack or HipChat.
right.
Rest in peace, HipChat. And it would send an instruction to an HTTP server, and that HTTP server would do the deployment for you. So you could type in your chat, deploy blah, 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 and it would work. And then I have worked on some open source projects and worked on pipelines for those. And those are often around building a release that goes into some package manager. And that's pretty straightforward, but it's like CI process where you're running tests, you're linting, is the code quality up to par? And then if so, you build a release and you get it into that package manager. That's pretty separate from what we're talking about here. I think the real big emergence over the last 10 years, real post Heroku, post cloud. So it's Heroku cloud. And then you started to see this split in our industry between Kubernetes and serverless. And I think you could have a whole conversation about serverless and Kubernetes and what that split means and why it exists. But Kubernetes has come closest to what I wanted, which was, I have a container, can you just run it for me? And there's still a decent amount of complexity in Kubernetes and still a decent amount of knowledge involved in deploying something onto Kubernetes. It's maybe easy enough if you're talking hosted Kubernetes. But if you go back to that concentric circles of knowledge I talked about, you still have all this stuff. I'm going to talk to a database. Where is that? I'm going to inject configurations. How do I get that in? I'm going to have a certificate for my service. Maybe that's set up for me relatively automatically. I've got load balancing. How does that work? And as an app developer, you end up having to know about all these Kubernetes abstractions to be able to debug your app if it doesn't come up successfully.
I've gotten to the point where I really like Kubernetes, and I think the complexity of it is definitely worth it if you are in a certain environment. You've got more than one service to deploy, and you've got things that need to scale, and you need to worry about what needs an ingress and what doesn't need an ingress, and what needs load balancing and things like that. I think it's a really nice abstraction over those ideas and deploying those types of things. I guess my problem with it is it's not a problem with Kubernetes. It's a problem with the world. Is that, like you say, Kubernetes is pretty good at saying, here's an image, deploy this for me, but the image usually isn't the application anymore. The image is a microservice or a part of an application, and so to make something that looks like an application to an end user, you need a bunch of those things.
A whole fleet of them. They have to interact reliably and consistently.
Yeah.
You may have in Kubernetes speak, you may have an ingress, which exposes your app to the outside world. You may have a front end group of pods, and you may have a back end group of pods or more. And maybe you've got a database, and you've got all these things that need to peacefully coexist. And you have to learn some of these abstractions to make sure that that works reliably. I think the contrast there is with serverless. When I think of serverless, I think of a thing that exists primarily to optimize for scaling. And when I think of Kubernetes, I think of a thing that exists primarily to optimize for deployment. Kubernetes makes deployment like it seems like the goal of Kubernetes is to make deployment as easy as possible. And that's what I want. And when you look at, say, AWS Lambda, the optimization is around, well, we'll scale to 0 and then we'll spawn it whenever a request comes in. We're optimizing for scale. We're not optimizing for deployment. And I think I tend to prefer the Kubernetes style because I want deployment to be as basic as possible. Is this a poor interpretation, do you think? Maybe I'm oversimplifying.
I don't think it's a poor interpretation. I do go back to this thing though. So we were both recently looking at this paper that came out of Google, I believe, called Towards Modern Development of Cloud Applications. And they talk about having this system where you write what's essentially a monolith, and then behind the scenes, something figures out how to deploy that thing onto the various servers that you might need to make that thing work. So, I don't think I necessarily want their solution because I feel like it's probably going to be too specific to their cloud environment. But that's kind of what I want eventually, is something where I'm writing an application and I don't have to think about the pieces of that application. I can just sort of move that to another place. So
Yeah.
I think you're right that Kubernetes makes deployment a lot easier if the unit you're thinking of is a service. Prior to Kubernetes, I was working with ECS on Amazon and had that same experience where, wow, this is, for the service that I'm deploying, this is a lot easier than what I was doing before. But it doesn't, I now have this situation where I have to do deploy a bunch of those things, and I have to make them talk to each other. And
right. And what if they get out of step in terms of what they're expecting in their contracts with each other? That's a whole problem too that emerges. That may be a microservices problem. I mean, going back to the serverless being not, my argument that serverless is not optimized for deployment, that gets exactly to your example. If I've got a Python app and I want to run SciPy or Pandas or NumPy, Pandas, very common dependency. Back when I first tried to use AWS Lambda, I discovered early on that, and I had already, been exposed to Docker. I discovered early on if I wanted to run a Python Lambda with pandas in it, I needed a specialized build for it because it has to emulate the environment it's going to be deployed into. And that broke something for me. It was sometimes people call this a leaky abstraction, but it's like I had to know a lot more about where it was going to go than I wanted to. It's sort of the promise was just write some code and get it out there. And I felt like that promise was not fulfilled.
Yeah.
I also think serverless is a giant vendor lock-in scam as well, but that's a different story.
Yeah, I tend to agree with you there. I have to admit, I have not kept up with the state of the art in serverless. I still think of being this thing which is sort of transient computations that are effectively stateless, so you can, start them, do something, and stop them. So I don't know what the best thing out there is now in the serverless world, but
they do have these things called step functions where there's intermediate states, but that's probably a side note. It's not. It's a orthogonal to what you're saying.
Yeah, I think there's also I think maybe Google's is it Autopilot? I'm forgetting the name of it, but they have a Kubernetes sort of thing which you no longer have to think about specific nodes. So it's kind of approaching. It's kind of a hybrid, I guess, of serverless and Kubernetes.
That's what I think is really what I want. The other benefit to Kubernetes is what I'm deploying to is much more common, I guess. As Kubernetes has grown in popularity, I can be on Azure or I could be on Google, and I have problems with my cert manager, right? Which is renewing certs for me, managing certificate resources. I can go on the internet and search for problems around cert manager, and it probably has nothing to do with the cloud that I'm on. So it's more generic. And that actually appeals to me. There's a larger community of people I can learn from and whose work I can benefit from. We can use an auto-scaling tool like Kata, and we can use the Nginx Ingress, which is open source, etc. So I have doors flung open to tools that I could load into my cluster. But as I do that, I am increasing complexity. I'm adding things. Maybe I'm adding a service mesh. This is complicated stuff. If I have to debug it, it goes pretty deep. I want to go back to, you referenced this paper from Google. The paper is called Towards Modern Development of Cloud Applications. And it's a really interesting paper because they have a Go-like language. And they say, let's no longer think in terms of services. We'll think in terms of writing code. And we'll have some engine, metaphorically, that interprets the code and figures out how it should be deployed and how it should live in its environment. That's a fascinating idea. I really like it. As I read the paper, I think, wow, this is great. It looks exactly like the Heroku mistake. It's an extremely specific, overly specified solution. And if you buy into that, it makes everything easy. But it's a big hurdle getting everybody to buy into that. I can imagine at Google, they can mandate that, so it'll work for them. I can't imagine that working outside of their ecosystem.
Yeah, I'm not sure. I mean, I do think there are so many common patterns now that it's conceivable that you could build something that is able to determine when it's deploying that I need multiple replicas of this. I need this. It knows, it can determine from context that you really do need an ingress for that thing, so on and so forth. Or maybe it can determine this should be a stateful set instead of a regular deployment or something. But I guess the former CTO in me makes this feels like a compliance nightmare to me, because there's so much going on behind the scenes that I don't have visibility to.
Be hard to give a diagram to your auditors about what's happening.
Yeah, exactly. It would be hard to explain to them who has access to this thing, and does this service, if somebody gets into this service, do they have egress to the outside world? Am I going to know that?
I agree. There's a lot of magic in there. Maybe the problem is I want a lot of magic, but I actually don't want a lot of magic. Maybe that's my fundamental conflict with deployment. I want a deployment to be a sheet of glass that I look through and forget that it exists. That's what I want.
Just needs to be more powerful magic.
So over the last 5 years, 6 years, I've been deploying primarily to Kubernetes. First, it started with manifests, and we had these build pipelines, which would build the Docker image and then use Kubernetes manifest to deploy it. And then it all turned into Helm. So it was easy to templatize for different environments. I have seen and interacted with a little bit Argo CD. That's a really popular style now called, which people refer to generally as GitOps. So you have a Git repo, which Argo watches and it sees changes and manages your deployments for you. We're not using that in my workplace, but there has been some talk about experimenting with it. I do have to say that GitOps reminds me of ChatOps a little bit, just because of the name. That's a shallow comparison. And then I've also used a little bit of Cloudflare. So Cloudflare workers, and I have built Svelte, which is a JavaScript framework. I built a Svelte app and deployed it to Cloudflare, and that was a brilliant deployment. It's off of a GitHub repo. There's a pipeline, and you just pretty much say, "Hey, Cloudflare, deploy this thing for me," and it is magical. We're talking a minute or less, and it's insanely fast, and it's all edge computing. So the edge computing really seems to be like next generation stuff. Edge computing could be static files, JavaScript, things like that. It could also be WASM, so you could have full applications. You see this talked about by companies like Vercel and Cloudflare and Fly.io. Vercel is interesting. You go to their website, and it looks really cool, and they're very popular, and I think that's great. Reminds me again of the Heroku mistake, because they have specific deploy your React app, deploy your Python app. And again, the question comes up, is this overly specified? What if I have to do something weird with, I don't know, cert management, or well, they probably handle cert management or something. I don't know. Maybe if I don't have an example, that I don't have a real objection. It's more the matter of, are you going to make it so that I can deploy a random Haskell app, or can I do that on your platform? Because the dream is I've got any arbitrary weird thing I build at any point in the future, and I want to magically get it out into the world. And deployment is more important to me than scaling, but I'd like to be able to scale it too. It's a dream deferred.
I don't know what the limitations of that are. I see more stuff these days about edge deployments, but I get the impression that it's often quite hard for things that are not just web pages.
Yeah, I mean, imagine I want to edge deploy something that wants to talk to a PostgreSQL server. Okay, so I probably have one writable server and then maybe some read replicas. Is that by deep? Like, I'm not saying how you would do it for scalability. I'm saying how you would do it if you're a cloud provider like Cloudflare and you're doing it as a default, for somebody like me.
A friend of mine posted something to LinkedIn recently about some work he'd done putting neural networks on an embedded device. Might have been a phone, I can't remember, but anyway, basically the long and short of it was they had to use a deep learning framework written in C, which I can only imagine is pretty arcane to read through. I do remember seeing recently, though, that the new Google Gemini, I think that's what it's called, the Gemini LLM thing, there's a version of that which is supposed to be able to run on phones.
I guess I will say that I expected when I got to Kubernetes, I thought, wow, I've been doing Linux administration, not as a primary thing, but as a side thing in order to get my apps deployed for 15, 16 years at this point. Kubernetes looks great. I could throw all that knowledge away. I'm never SSHing into anything ever again. And I was eager to be able to shed that knowledge. I think sometimes in our industry, we get a little bit committed to the hard won knowledge. I know how to configure, a VPC in an AWS and a NAT gateway. I know the stuff, and that's important knowledge. But as a software developer, I feel like it's not important to me. I don't want to know. I may know it. I don't want to.
I have mixed feelings about that. I mean, there's stuff I've learned over the years about Linux networking and firewalls and stuff that I've totally forgotten and would have to Google on Stack Overflow to do again. So I guess I have to concede that it's not that important to my daily work, but I do feel like I've lost something by forgetting how to do that stuff.
Yeah, I guess I'm not saying everyone should forget it. I guess I see that stuff as kind of plumbing. I want to know layers of the stack and how my stuff interacts with it. But if I didn't have to, I'd be fine not knowing too. If everything just worked. If I didn't need that information to debug it or to have intuitions about why a socket connection closed or whatever at some weird point in the lifespan of my application.
I guess it's true of our profession in general. I mean, we were recently talking about how back in the old days, when you started a new project, you might have to write your own linked list implementation. You might have to write your own sort algorithms, and very rarely do people do that anymore. So,
well, I still feel all the animus, but I don't feel we're not good at resolving these things for me. All right, that's our deployment discussion. We're just going to sort of leave the fire hot on that one. We'll come back and talk about serverless someday and microservices someday.
The objective was not to solve the problem. The objective was to complain about the problem.
Oh, good. Yes. So here we are, weekly complaint session. Go. All right, Mike. Nice hanging out with you. This has been Picture Recoding. My name is Erik Gaker. Co-host Mike Mull is with me. Thanks again, Mike.
See you next time.
See you next week. Bye-bye.